Yes, thank you, Luna. Thank you very much. And thank you all really for the invitation, actually, and having the privilege to open up the series of webinar dedicated to this project. And it's really very nice for me to be here to talk about one of the things that I have dedicated a lot of my time recently is regarding science and policy dialogue. And this comes not only by a personal interest, but the fact that working at the Joint Research Center, which is a Directorate General of the European Commission, we actually been able to take the scientific outcome and then somehow provide which are the messages to our colleagues in Brussels. So first of all, I would like to acknowledge also the contributions of my colleague Agostino Inguscio. In reality, this presentation is indeed a science policy dialogue itself, because I'm working at the Joint Research Center while Agostino is working at the Directorate General for Research and Innovation. So indeed, is a part of this game. And then the idea to focus the attention to exactly a period that has been quite important for the policy development for what concerns climate change and not only. And the decision to exactly focus the attention on that part of our developing of the policy is to show exactly how science played a role in these last years. And then I like to start actually this seminar with this quote about vision, because I think this is what science and policy have in their DNA. Science, because many times really is able to look so much further than what usually eyes can see, and even in the future, and looking ahead of what can really happen. At the same time, this is something that the policy should have, not only try to look at what is happening now, but indeed looking towards the future and finding a way forward in that respect. And in both of the cases, really, they see many times things that usually are not so visible or so easy to see. While this presentation will be focused indeed in the development from the Paris Agreement, of the EU climate action from the Paris Agreement to the European Green Deal, science has been really instrumental for the policy or international agreement development already back in time. And therefore, I will start this presentation exactly looking a little bit back in time, first of all, and then really focusing on the attention from 2015 on. And indeed, this is a sketch of which were the development of science regarding climate change, and particularly those funding that were related to the human impact on climate. And while we know very well that this impact has been visible or from the Industrial Revolution on, or almost after that, after the beginning, it is quite interesting to see that the first people, the first, they were not scientists, that they were historians, that they were free thinkers, they were philosophers, that they started to think that men could have really an impact on climate change are back in the 17th or 18th centuries. At that time, those thinkers were looking at the change of climate, both in Europe and in North America, and then relate the change of climate to the actions that mankind had, clearing the forest, for instance, that massively were taking place in the United States particularly, but also Europe, and also changing the land use by the agriculture and other use. So they were the first to think and to imagine that the man could have such an effect. And indeed, we come to the 19th centuries, where indeed the science that actually provided the basis of what we know on climate change took place, starting from Fourier, who was the first indeed in 1834 to understand that actually what was determined the temperature over our planet was due to the presence of the atmosphere. Later on, the Tyndall pointed to which were the actors on this, only right after a few years, and then saying, well, water vapor had a very important role, but also other trace gases, such as CO2, for instance. When we come at the end of the 19th centuries, the Swedish physicist Svante Arrhenius was the first really to pointing to the role of CO2, of the effect of the temperature. Actually was the first to make an attempt to evaluate what was the impact on the temperature if we were doubling the concentration of CO2. And he was the first to say, well, think that the concentrations of CO2 in the air is the one determining exactly the changing between the glacier and the interglacial area. And all this already at the time. Now we come in the first decades of the 20th century, where indeed a more modern way to look at these measurements took place. And indeed, Callender, a British engineer, actually took 200 meteorological station data and realized, analyzing those data, that actually an increase of the temperature was already taking place in the last 50 years. So, and he pointed to exactly the fact that were the fossil fuel from human activities that were related to that increase. Now we come in the middle of the 20th century, where really the theory of the impact of CO2 on the climate was put in place, where indeed more elements of such a theory were put into place exactly in the 50s. And even one of the most important elements was the realization that the ocean could not pick up any longer, which was the excess of this CO2 in the air. And therefore, this is why it was accumulated due to the activities, human activities. In the 58, a very important monitoring program started by Charles Keeling, that he started really to monitor the CO2 in Mauna Loa. And already after a few years, it was evident that indeed the concentration of CO2 were increasing. But he spotted also a very important element, which was the annual cycle of CO2, and really looking at the fact that the planet was really breathing. So this was very important. So let's say that by the middle of the 20th centuries, we knew already a lot of what we could consolidate on, clarify, or later on. The first attempt to use science into a policy arena was done actually by the President of the United States in 1965. Lyndon Johnson asked his scientific advisory group actually to write a report on the status of environment. But that report contains a chapter dedicated to CO2 particularly, and also that chapter in the conclusion points to the human impact of the increase of the CO2 in the atmosphere, and the fact that something really needed to be done on that respect. However, nothing really happened. And except that in Europe, but not only Europe, later on, all the process of involving science in the policy cycle indeed started. And then I would like to show that period, exactly showing this timeline where we see, starting from the end of the 80s, the development of not only the creation of the Intergovernmental Panel of Climate Change, the adoption of a United Nations Framework Convention on Climate Change, but also the development at the international level, or the attempt at the international level to arrive to various treaties, including the protocol, Kyoto Protocol, and then the preparation to the Paris Agreement. And I want also you to know and to look at the fact that even in Europe, the different attention and then to actions that could be important for the mitigation of climate change and the impact of human on that started already in 1990. And in fact, if we impose here, actually, when the different IPCC assessment took place, we look at the first actually was published in 1919, and as a result of that report, the European action started to be put into place, and also the adoption of the Convention on Climate Change. We see already in this time scale that those assessments were really instrumental for the development of the actions and the policies. Also, the second one, in preparation of the Kyoto Protocol, the assessment report 4, in the preparation also of the target of the 2 degrees, the fifth before the Paris Agreement. The next one will be in 2021, but I put here also in green this report on the global warming of 1.5 degrees, because that report, we'll see in a moment, plays an important role in the development of the policies from the Paris Agreement on at least at the European level. And I thought that it was interesting also for you to know how the IPCC actually was born. And in fact, the IPCC is exactly the point in which science met politics. This happened through a series of different international scientific conference, like the first World Climate Conference, as well as the United Nations First Earth Summit, where it was really written that the government had to be aware of the activities that were impacting really the climate. Now, through a series of workshops under the umbrella of WMO and the UNEP, and the in particular involvement of USA in this process, because the USA at that time, exactly as in the 20th centuries, had a very, very important and well-developed science that was related to climate change. And finally, in 1988, the WMO Secretary General invites finally member states to agree on the establishment of the International Panel on Climate Change. So that just to explain that in reality, in a certain moment, even though with some difficulties and so on, these two things together start really going on the same track, or at least to start with that. And now let's move finally from the Paris Agreement upward. The Paris Agreement, as we know very well, has many, many aspects within, not only targeting mitigation, but also targeting adaptation, for instance. And there's also other actions within that we will not touch upon now. We are just, I thought, to focus my attention on two different strands of the Paris Agreement itself. First of all, the temperature and emission reduction targets, which are really pointing to what we know very well, the fact that the intention is to keep the warming well below 2 degrees and basically try to really limit the increase to 1.5 degrees. And then, of course, this can be done just if there are reductions of the emissions and target within that. And then these targets implies that these emission inventories are peaking quite soon, but from 2020, there is the aim to achieve the balance between emissions and removals. So going to what we know is the climate neutrality. And the second strand that we are going to see later on is a very important mechanism, which is also part of a policy, which is a review mechanism. So we need to know where we are compared to the targets that we set before. And this has to be done, and in particularly for the Paris Agreement is every 5 years. We'll start with the global stocktake in 2023. But there is also a request to have really a robust and independent, transparent and accountable systems. And we see also in that respect how science is helping in this development. Now, back again to the targets, both in terms of emissions as well as the temperature target. Let's look on what it means in terms. What you see now and through all the presentation, particularly related to the scenarios, is the results of science. So this is really the way in which science has been instrumental for this development. First, a look of the situation as it was right after, let's say, the Paris Agreement. So this analysis done by the JRC show exactly the evolution of the greenhouse gases emissions, considering 4 different scenarios. We are looking at the time series now. In the left hand, the greenhouse gases emissions. The reference scenarios in yellow is a reference scenarios where no other policies are put in place beyond 2013. And indeed, what we can see looking at the right is that the temperature would grow well beyond the 2 degrees, up to more than 3.5 degrees. But if we consider the national determined contributions, which were exactly the contributions that the different parties of the Paris Agreement put into place, it is in the blue line, we see that actually, although certainly doing a better job compared to the reference scenarios, they are not enough to remain below the 2 degrees. Now, the last 2, the green one and the 1.5 are indeed the 2 preferred option, but it means that the picking of these emissions must be really happening now or very, very soon, as we can see in this timeline. But also it is important to see that if we go for the 2 degrees scenarios, we will hit the 0 emissions by 2080, and while for the 1.5 a little bit after the 2060. So this was what actually we had in front of us exactly right after the Paris Agreement, I would say. I report here this analysis that was published on Nature some time ago regarding a check of the national commitment versus which were the targets of the Paris Agreement. So here we have the national commitments color-coded, with the from the pink and the red are the ones that we will not be able to meet, support the reaching for the target, because that will be their consequences will be above the 2 degrees, while the blue ones are the one that they would be okay to reach for the target. But what we see here that the major emitters, or among the major emitters of the greenhouse gases, many of them, according to this analysis, would not, their national commitment would not be enough to reach for the target. Now, then let's imagine that we will go for the 2 target scenarios, but let's start to look at what it means. And then this is also a step forward in the analysis that was done within our house to try to understand what it meant to reach for the 2 degree scenarios. What we are looking here is we are now taking a look of the world primary energy demand. Sorry, I didn't put here the reference, but it is exactly the same reference that was there. Now, in terms of energy, we are looking now at the global. By the way, on the upper right level, you see these multi-flag appearing. When it is when those multi-flag circle is appearing, it means that we are looking at the global projections. In a certain moment, you will start to see the blue one with all the stars, and that means the European one, in case in which I forgot to say. Now, looking back again to the primary energy demand, we'll see that if we project ourselves going towards 2050, we see a decrease of this demand. And this is basically due to the considerably energy efficiency that we think is going to put forward and then taken on board. But then this demand will grow due to the fact that there is a continuous economic growth, but also the standard of living may be increasing with the time. We see here three important elements, and that's why also I show this graphic. First of all, the renewable energies, which are going to take a more and more important place in what concerns the energy demand. We have the low carbon sources. What are the low carbon sources? Are those sources that for which we can go from a very high, there are the high emitters of greenhouse gases that could be actually turned to low carbon emitters. For instance, changing the fuel, maybe going from coal to gas, for instance. And then we have in the brown, the unabated fossil. So there are the sources that we will not be able, according to the analysis, to really decrease until 2018, we had climate and energy targets for the EU for the 2020 and 2030. They were based on three pillars, which were the greenhouse gas cuts versus the 1990 levels, the renewable energy targets, as well as the improvement of the energy efficiency. Now, what I like you to point to the fact that for the targets of 2020, we are on track on reaching these targets. But in 2018, we had a revision of all the targets for 2030, and then we had 40% reductions that were foreseen by 2030. In reality, the European Green Deal that we'll see in a moment changes the paradigm of that target. And what actually happened was indeed the publication of the IPCC special report on global warming. This report actually shows very well that if we go for the 2-degree scenarios, the impact will be still quite dramatic. And therefore, just to avoid that this happens, we need absolutely to reach for 1.5 degrees. And this has been very, very much instrumental for the further thinking within the Commission and the development of the policy. And indeed, this was also put forward when in 2019, the European Green Deal was communicated by our president, Ursula von der Leyen. And then she showed it really with this sentence that is Europe's man on the moon moment, because in reality, that communication and that program targets not only to the decrease of emissions, so mitigating the climate change, but really changing the paradigm within Europe, and then reconcile as well the economy with the environment, our planet, and so on. So we will see in a moment that is a quite complex system to make this change really happening. The European Green Deal brought with it also the new proposal for the targets for Europe by 2030. And then these targets were risen to 50%, but later on there was also a proposal for the 50% reduction for Europe, with the idea to reach for climate neutrality 2050. The climate neutrality 2050 is one of the pillars of the European Green Deal. Now, I still remind that when we talk about climate neutrality, we don't talk about decarbonize completely the system, but it's really finding a balance at net zero emissions, so a balance between emissions and removal. The complexity of the European Green Deal lays also on the fact that to reach for such a target, the transformation must really take place, also to reach for those targets. And then the transformation implies really many policies that have to transform themselves, new different strategies that were put into place really to be able, or will be put into place to really have this transformation really happening, because they target which are the major sectors where currently, if the situation remains as it is, will not make it possible to reach this climate neutrality by 2050. And we see it also here. This is another result of another study where we are looking now at the evolution of CO2 emissions by sectors, following the reference scenarios when it was at 2019. So the new targets by 2018 were already taken into account. But these scenarios shows that indeed, if other policies were not put into place with the European Green Deal, we will not be able to reach at all the carbon neutrality by 2050. So now how this can be done? And then again, science is the instrument for that. Now, what science does is really the preparation of the possible scenarios. Now we set up a target, the policy set the target to reach, and science try to understand and evaluate which are the different ways in which that target can be reached. And it is based on a series of choices in terms that are related to energy, economy, and the environment, and so on. And so science prepares the scenarios and put on the table of policymakers those scenarios. Now it's the policymakers who makes the choice and decides that beyond the vision where we want to be, this is the way in which we will go. And usually this is done, of course, through models. There are many models that can do this work, either looking at the energy consumption, but also how it will be the changes, the technological changes, so the structural changes of the future. Economy is a very important component of such a models, but also the environmental part and the agriculture and the land use. Now we're going to see actually which was the scenarios that at the end was chosen to be underlying the European Green Deal. And just for information, all you can see, it is publicly available. The impact assessment that was done on the models is available. So if you are curious to see the results and how the scenarios were put into place, you will see it. But what we are going to see was developed by the combination of the primes model together with the primes for the energy, the globium for the agricultural land use, and a gains for non-CO2 greenhouse gases. And then we will see that also there was a study on the impact on the air pollution as well. Now this is the scenarios that underlying all the policies and the choice in the policies that the European Green Deal contains. We are looking now at the greenhouse gases emission. This is the trajectories to reach for the 1.5 scenarios. We are projecting ourselves until 2050, where the red lines says that indeed by 2050 that lines reaches for zero. To reach for this goal, there are some strategic decisions and building boxes that are there. And I invite you really to look and understand what all this implies. And of course, the renewable energies will have to be developed, the renewable energy needs to develop more, and then the use of electricity is implied really to to be one of the most important actors. Energy efficiency is going to take quite an important role, and it will be also for the decrease of the emissions due to the power sector. The transport is plays an important role on the greenhouse gases emission, but there is also there, you see also other strategies that have been or will be put into place. And also one of the things that needs to strengthen is really the creation of the carbon sinks, either through the LULUCF, so the land use change and forestry sector, as well as the carbon removal technology. One thing I wanted to underline, a couple of things I wanted to draw your attention when we look at these graphics. First of all, the fact that while the projections show that for the power sector, we will be going quite well down in the emissions, as I said, due to the increase of renewable and the energy efficiency, both for the transport as well as for the industry, this is not really the case. So we will not be able to completely decarbonize the system and be able really to go down to zero emissions. Now, if it means that the other sectors, which are the sinks, needs to be developed. And while the LULUCF plays already quite an important role here, we see it, we'll see this growing blue line of the carbon removal technologies. And then I wanted to draw your attention to the fact that while these technologies, the conception around the technology or the system is there, technologically, we need really to advance quite a lot to be able to use this as an efficient sink. And then there is actually a program, a fund program, the Innovation Fund program of the EU, where really is targeting the development of the carbon removal technologies, as well as the low carbon sectors. So now we come to put in place, actually, once that the vision is there, once that we have decided what is the path that we are going to follow, we need to make it happen. And to make it happen, there are two different or two complementary actions that needs to be put in place. The first one is really targeting, most of all, the climate part. And then you know that a climate law really enshrining the climate neutrality objective by 2050 was put into a legislation. The 2030 climate target were risen, as we have seen. There are really the revise of many legislative measures that are necessary to take place. And then you there also down to the slide that you can see where are the building blocks of that will support to the climate, this climate ambition. And there are also other points, other important strategies that needed or needs to be revised so that we are really able to come to that respect. From the beginning of 2020 until now, some of these strategies were put into place, and they are more or less connected to the climate ambition, either directly or indirectly, changing the technology, changing the way in which we do things, trying to establish changes which are not necessarily technological, but also of behavior and so on. And then one point I wanted to make here about really indeed the climate neutrality and the zero air pollution. Of course, this slide comes right after the very nice discussions that took place on the 26th of October that you organized for the launch of your policy brief. And then indeed, the question that you posed was quite a legitimate question. Now, what actually is happening under the zero air pollution. First of all, the zero pollution ambition is really trying to look not air, not water, and not soil alone, as it was done and so far, but really looking at this as a whole compartment to try really to optimize the things so that also air will benefit from this. Within the clean air part of the zero pollution, there is also, I mentioned already, the decision of opening up the discussion on the air quality directive, and then looking also at the actual limit values. But there are also sources that they are targeted to low down the impact on air quality. Industries is one of them, but the transport plays still a quite important role. We saw it already for the climate change, but we know it plays a role also for what concerns air pollution. And then not only the transport on the road, but also the maritime transport as well as air and so on. So there are a lot of actions that will be put in place really to limit as much as possible the impact on the traffic on that. Just for you to know that actually there was also an impact in the impact assessment, also the effect of these 55% greenhouse gas reduction target by EU impact on air quality. And then what it is seen that these against made this analysis that the decrease of the air pollutants when by reaching for this 50% target for greenhouse gases will be down to 60% compared to 2015. Now, one of the things still related to policy, which is related to policy already taking place, already in place, is exactly that the NEC directive, so the National Emission Ceiling Directive, which was adopted in 2016, already put forward among the actions to mitigate the problem of air pollutions, also the ask to privilege those actions that are limiting, for instance, black carbon. So there is already an eye on the fact that we need to privilege those solutions that are really limiting the warming agent and so on. But still, as it was already mentioned during the meeting the other Monday, is that we should not forget that air pollution is still quite important killer in Europe. And then the fact that almost 400,000 people are really dying prematurely by air pollution in Europe is still a quite important number, and we need really to address this. Now let's move towards the last part of the presentation, which address the review mechanism. So how actually science can help this part of the agreement. Well, first of all, a revision is a revision of emission inventories. And then we know basically three major lines of work or different ways to compile emission inventories or to evaluate emission inventories. The first one is done by the member states or the signatories of the United Nations Framework Convention on Climate Change, where they submit their national numbers for the greenhouse gases. Another way to do that is how we do it in the EDGAR database at the JRC, is looking at the emission inventories with an independent view, not starting from what is reported by member states, but really starting from international statistics and building these emission inventories. And then the third methodology is through inverse modeling. So it is a completely reversed way. So we start from the in situ and satellite observations. We apply usually chemistry transport model, we inverse the mechanism and we come to evaluate the emissions. Of course, if we do that, we have to consider that in those emissions that we infer with this methodology, we consider as well the natural emissions, because of course what we measure in the air contains also as well. But there are also techniques to really disentangle this. Now, the first two ways are called the bottom up, and the second one are top down. But we must also remember that the emission inventories or emission evaluation is really a very difficult thing to put up, evaluate, and assess. Therefore, usually what you do is really putting together different ways of evaluating emission inventories and compare one to the other. There is no real number in terms of truth number. There is always an uncertainty related to emission inventories. And while it is so difficult, I take here the schema for Edgar, but it's the same for many, because we have many informations that we need to have at our disposal really to do that. We need to know where the sources are, which sources are. We need to understand also their strength, and then the sources are many, but also the emission factors which will give the strength of the emissions of that source are really many. And then we may not really need just emissions at national level. We might need also to grid these emissions, so to have an idea where these emissions are coming from. But also to do that, usually we use proxies for this process, and then this implies also to have other uncertainties coming in. And in fact, we touch upon the uncertainty of the emission inventories. And again, here I'll show the one that is related to Edgar. Just for the greenhouse gases, we are looking CO2 and methane and N2O. And on the right side, you see the different sources of these three important greenhouse gases. And for CO2, for Edgar, what we see is that the uncertainties related to CO2 are within 5–15%, but the highest uncertainty are for N2O, and particularly on the agriculture sector. Also, methane has a quite important uncertainty, particularly in the field of the enteric fermentation, so also the agriculture part, let's say, as well as waste. We are now, of course, here talking about anthropogenic emissions and not the natural emissions. So, and how all these it will be taken into account while the Paris Agreement will go through its review process. The review process of the Paris Agreement has different steps. Of course, national determined contributions will put into place. They will be revised. There are two major bricks in this revision. One is exactly the what is the track of these national determined contributions, and this is done biannual, while the global stocktake will look at every 5 years to assess exactly what is the collective process towards that target. I wanted to point to you the attention to the fact that the IPCC will play a quite important role in this cycle, because indeed it is expected to provide the input by 2021 in the preparation also of the global stocktake in 2023. And of course, this implies hopefully also for the next assessment report coming out. So already here, there is this hand-in-hand path that the two things are going forward in the future. But also the other important element of science is the development of the independent verification system. Independent by all members, so looking in a way, in an independent way by the nation to what is happening, and 2, the emission inventories at the global scale. Now, this is done, it is done with a collective work and effort started already under the Horizon 2020 project Verify, and the project is still ongoing for more than a year from now. And the idea is exactly to find a way to use the bottom-up and the top-down estimates of emission inventories and try to derive a way to have this verification system into place. So I wanted to conclude this seminar really to say that indeed what we unfortunately see with the climate change is indeed we are surprised by the speed in which the process is taking place. And this is what we found it perhaps not impossible, but different, unforeseen, so such a speed. But indeed what of course I hope, and then I'm very confident that science will always provide the what is necessary, and then what actually is important to policy in order to develop for the future. And this is exactly how policy should develop, based on the, what really science can provide as knowledge. Thank you.